So we're going to try a new format. We're going to do least common multiple today, and we've got some interesting sounds to accompany this lesson. Least common multiple is lesson 3 in chapter 4, and it is similar to GCF, but not the same. So let's make sure we make the distinction between factors and multiples. So sometimes it's hard to actually write it in words, but I think in an example it makes it really clear. Factors of 10, they're smaller numbers, right? They're numbers that go into 10 evenly. 1, 2, 5, and 10. It's a finite number of factors. There are a finite number of factors in 10. Multiples of 10 are numbers that 10 itself can go into. 10, 20, 30, 40, 50. And it is not finite, it's infinite. They go on and on. You can continuously find multiples of 10. So what I should say is dot, dot, dot. So my dot, dot, dot went away, but basically here it is. Dot, dot, dot. Okay. Least common multiple is looking at two or more numbers or number expressions and finding the smallest multiple that they have in common. So if you look at two different numbers, you look at all of their multiples, you want to know what the smallest multiple that they have in common is. That's where it comes from. Least common multiple, otherwise known as LCM. Okay, let's hear what the chimpanzee has to say about it. I think he likes it. Okay, so now let's take a look at this example. So I've got the first two I'm going to do are 10 and 15. So if I've got 10, I can list out its multiples. 10, 20, 30, 40, etc. If I look at 15, I've got 15, 30, 45, 60, etc. So what is the least common multiple, the least multiple that they have in common? Well, it's fairly easy to see here because you don't have to list for very long. It's 30. Least common multiple equals 30. Okay, so that's one way to do it. But then what happens is that the numbers becomes a little bit more difficult. 15 and 36, you may not know off the top of your head what that least common multiple is. And if I list it out, it could end up taking a really long time to get there. So what I'm going to do now is I'm going to start by breaking it down into its basic components, like we did for GCF. So we're going to do the prime factorization of 15 and 36. 15 is 3 times 5, 36, is 2 squared times 3 squared. Okay, so now to find the least common multiple, or the multiple that they have in common, now it's going to be very different from the GCF. I'm looking for a number that both of these numbers go into, that 15 goes into and 36 goes into. So I'm listing all the factors without the overlap this time. So how that works is you start with the smallest number on both of your lists. So here's one list and here's the other list. The smallest number I see is 2. So I see 2 squared. And there's no other 2, so I have to list 2 squared. So in my LCM, I list 2 squared. Okay, times. Now I go to my 3's. 3's, I've got 3 squared here, and I've got 3 here. This one over here has 2 3's, 3 times 3. This one over here has 1 3. I don't combine them, I just look at which one has the most. This one over here has the most, so I'm going to list in my LCM 3 squared. Because I can find 1 3 in there, but I can also find 2 3's in there. Okay? And then my next number is a 5. There are no other 5's on the board, so I have to include it because both my numbers need to go into it. So 15, remember, was 3 times 5. Do you see a 3 and a 5 in that number? Yes. 36 is 2 squared times 3 squared. Do you see a 2 squared? Yes. Do you see a 3 squared? Yes. So therefore, both numbers exist in this LCM. I do want you to take it a step further and multiply it out. This gives me 4 times 9 times 5, or 4 times 45, which would be, anyone? 180. So my LCM is 180 because I'm running out of space over there. Okay, let's see what our bear has to say about this. He might be mad. I couldn't quite tell on that one. So let's go to my last example, which is one I'm going to make up. Okay, this one's going to have variables in it. So I have 70 x to the second, y to the third, and 15 x, y to the fourth. So now it's not going to be too much different. I'm going to start by doing the prime factorization of both. 7 times 10, 7's prime, 2 times 5, and I get 2 times 5 times 7 times x squared times y to the third. Okay, then I'm going to do 15, where I'm going to do 3 times 5. I've used that example a lot this lesson. 3 times 5 times x times y to the fourth. Now for my LCM, I'm looking at creating a number that both of these numbers exist in. So I start with my smallest, which is 2. There's only 1 2 on the board, so I'm going to list 1 2 for my LCM. Next, I'm going to go to my next smallest number, which is a 3. There's only 1 3 on the board, so I'm going to list that one here also. Next, I'm going to come up with my next number, which is, I see a 5 here and a 5 here. I'm not going to list 2 5s, I only need 1, because I'm doing this enough so that I can find both numbers within my LCM. And then finally, I've got a 7 and a 7, or sorry, just 1 7, so the 7 goes into my LCM. And then for my x's, I've got x squared and I've got x. So I look for one that can contain both of those, and that would be just x squared. And then y to the third or y to the fourth, I need to have the larger of the two, y to the fourth. So that this way I have a y to the third in there, you see a y to the third in there, and a y to the fourth in there. So do I see 72 times 5 times 7 times x squared times y to the third? 2 times 5 times 7 times x squared times y to the third. It's in there. 3 times 5 times x times y to the fourth. 3 times 5 times x times y to the fourth. It's in there also. So then I just need to put it all together. And I get 6 times 5 times 7, or 30 times 7, or LCM being 210 x squared y to the fourth. Okay, and what does our camel have to say about that? Where is he? Come on, camel, tell us what you got. That's reminding me of a Star Wars theme. I think I need to do a Star Wars theme on one of these. Okay, thanks. We'll talk to you soon. Bye.